So in chapter 2, we're looking at arguing, which some of you like doing. So you will enjoy this chapter. We're going to start by looking at patterns. That's what this whole section is about. And then making an educated guess based on a pattern. That's what inductive reasoning is. So we're looking at these patterns, and we're going to look at multiple different examples. First being number patterns. So looking at this one right here, there are, hold on one second. There's two ways that we're going to describe how we got each of the following patterns. So I'm going to show you both ways. You can do either on the homework when they ask you how you got your next two numbers. So we're going to get the next two, I didn't write that, the next two numbers in the sequence. First of all, what are the two numbers? You can just say them out loud. Okay. And that would go on forever. Okay, one way to show that is to use these little V's in between each one and say, well, it was plus 2, plus 2, plus 2, plus 2, and that goes on forever. Or you could write it in words, add 2 each time. Okay, so either one is fine. I'll show you a advantage to using this format when we get to C down here. What is happening on B? Don't tell me what the next numbers are, but what would I write as the description? Yes. Multiply by 2 each time. Okay, so you could also put times 2 times 2 times 2 in between each of the numbers. So that would be what?
48.
Okay. Now on the next one, it's not very obvious when you first look at this list what the pattern is. It's actually a double step pattern. So in order to see it better, anytime you don't automatically see the pattern, it's good to write down what we do see. So I'm going to make this a little bit bigger here. Okay, so we're going to look at what's happening in between each of these numbers. What's happening here? Okay, hold on to that in a second. What's happening between here?
Going up by 8. 7.
What about here? Here.
28.
What about here?
36. No. But yeah.
Okay, what's the pattern here? Same here? Okay, so this would be a potential description of how you're getting this pattern. What was the one that you said earlier?
2 plus 6 plus 3.
Multiply by what?
2.
Then add 6. Okay, so if let's try that from here to here, see if it works. We times it by 2, we get 44 plus 6, 50. Okay, so that one works as well. So you could write it like this, or if you don't see that pattern right away, just by looking at the list of numbers, this would be an okay description of how you're getting the numbers coming after it. So using either this one or the number one that we did over on the right, what would our next two numbers be?
Big numbers.
I don't think that's right.
I don't know.
Times it by 2, you get
A big number.
884 plus 6, 890. Okay, so either one is acceptable on the homework and also on the test when you have a number pattern, when they ask you to describe how you got that next number. Questions? Okay. The next vocab word here is conjecture. This is a conclusion reached by inductive reasoning. So going back to here, these are our conjectures. So you could draw an arrow to that. They're just an educated guess, okay, based on the pattern that we were looking at. So that's a conjecture. We could also have a pattern with pictures. So we need to put down our conjecture of what the next picture would be. So I want all of you to do that right now, and we'll see if it matches what I draw up here in about 10 seconds. I'm not going to judge you on your art skills. Hopefully, you drew that.
Kind of looks like
Now remember, it's an educated guess, so maybe the pattern doesn't continue this way. We'll talk about that in a minute. But a conjecture is based on the pattern that we see. This is what I think would happen next. Looking at a problem like this, the nice thing about math, and one reason why I really like it, is math is all about finding a shortcut. Okay, I don't know if you've ever thought about it that way, but we're looking for a pattern of events and then coming up with a formula or something to find the answer a lot quicker. So right here, the question is, if you add 5 more rows to this picture, how many small triangles would you have altogether? Now we could draw 5 more rows, draw all the triangles, potentially miss a couple of triangles when we're either drawing them or counting them, or we could look for a pattern first. So let's look at how many maybe are in each row. How many are in the top row?
1, 3, 5, 6.
What's the pattern?
Oh, like it.
Going up by 2 each time. So let's add 5 more rows. And then what do we do with those numbers?
Add them all together.
We just add them all together because that's what the question is. How many would you have all together? Let's get 3 people to agree on this number. Last hour, the people counting it in their head were quicker than the calculator people. 81? Another 81? It is 81. Questions on that? So look for a pattern so that you can create a shortcut for yourself. It's a lot faster to do that than to draw 5 more rows of triangles. Questions? Okay, so we've looked at patterns with numbers, patterns with pictures. This was a word problem using patterns. Now we're going to look at some scatter plots. So this problem right here, a rollerblade shop discovers that over 5 consecutive months, their rollerblade sales have decreased. Using inductive reasoning, which remember is using a pattern, so we're going to look at the pattern of events. Make a conjecture about how many rollerblades they'll sell in August. So your stars on your notes obviously aren't going to move, but mine do, so you can just draw a little dot. But here's our data right here with the months. So you need to put a dot above March that's at 110. April was 80. Something like that. So it's not a straight line, but it's pretty close to a straight line. When we draw scatter plots, what do they typically ask you to draw on your scatter plot? Dots, yes, but what should we draw on top of all of those dots? Yes. A line called the best line of fit. Okay, is it going to connect and touch every data point? No, but you want it to go through the middle of your data as much as possible. So something right along here would be good. So after you get your 5 points on there, you want to connect through the middle scatter. And based on that line, that's our pattern line, best line of fit. We want to predict or make a conjecture about where August is going to be. So where should I place this star? On the line, right above August, right? About how many rollerblade sales do we predict they will have if it follows this pattern?
35, 40.
37.
Somewhere between 25 and 30. Okay, this is a conjecture, and we're basing it off of a scatter plot, off of a line that you draw that you hope is straight. Okay, so there's going to be a range of correct answers on this. Okay, so somewhere around 30 would be a really good answer. Okay, that used inductive reasoning based on the pattern of rollerblade sales. Our conjecture is that they'll sell about 30 rollerblades in August. Now, is that for sure going to happen? No.
Could come in by this people.
Exactly. Maybe people like buying rollerblades in August and sales go through the roof. Okay, now along with that idea, the very last thing I want to talk about is that conjectures aren't always right. Okay, it's just a best guess, an educated guess. So let's look at this pattern right here. If we have a circle and we put red dots on the outside and then count how many pieces it gets cut into when we connect them all, how many pieces is this? How many pieces here? Here? There's 8 right there. So when we have 5 dots on a circle and we connect them all, we get 16. That follows the pattern, right? What would 6 dots be? 32. So I drew the picture here. Are there 32?
What's the biggest number? The biggest number is 30.
The biggest one on there, yeah, there's only 30 pieces that it got cut into. So the pattern does not continue, okay? It wasn't 32 like we thought it would be. So conjectures aren't always right. This right here is what we call a counterexample. It proves something is wrong, okay? The conjectures that we're going to be looking at in the book when they're wanting to talk about counterexamples are number examples. Okay, so one example, I believe one of the homework problems is when you, let's write this down, when you multiply 2 numbers and the answer is positive, the 2 numbers were also positive. Sometimes that's true, but this is a false statement, right? What would be a counterexample, which is a specific example to prove that this sentence is actually wrong? There are an infinite number of right answers here. Sure. Give me another one. Give me another one. Maybe not along that same pattern. No. So -1 times -1 is a possible correct counterexample. Give me something different that would also work. -2 times -1. Do these 2 numbers have to be the same? No. You could pick any 2 negative numbers. See how we got a positive answer, but we didn't start with 2 positive numbers. So either one of these would be fine. You could take -3 times -10 equals +30, and that would be a counterexample. You're just trying to prove that this sentence is false. These are both counterexamples in blue right here. Does that make sense? So you're arguing against this false statement. Okay? Questions?
Arguments?